Hello everyone, you are all welcome to lecture number 1255, and today's topic is thermodynamic requirement for chemical reaction, and here I will be discussing mainly for organic reactions. So when we are talking of reaction, is nothing but chemical equilibrium. And chemical equilibrium means a reactant and product. For example, if I am writing here A plus B, and it is an equilibrium means it is reversible. If half arrow is there, means left and right, and it will be M plus N. So it is like that, and where both side it is reactant, AB are reactants and Mn are products, and all these are on the basis of energy change. What are the heat energy requirement? And as you know, every matter is containing some amount of energy, and when it comes to change its energy, first the matter or molecule, it will start rotating. So that rotation means rotational energy will be changed, and when more energy is gained, is supplied, then its other energy that is vibrational, it will start vibrating, it will change, and finally if more energy is supplied to the system, if I say system means reactant, and if I say surrounding means outside, and then it will be having electronic change. So all this equilibrium is based on system and surrounding. Let me give you a very simple example of that. That if suppose you have one cup of tea, very hot, if you put on table, that cup of tea is containing lot of heat energy. Thermodynamic. Thermo means heat, dynamic means power. And once work is done, then it is second law of thermodynamic. First law of thermodynamic means conservation of mass. Any material, neither it can be created nor it can be destroyed. Only one form of AB can be transformed into new form of Mn. That is chemical reaction, where the chemists are the scientists who are capable of transforming and changing lot of matters into new amazing things with the help of chemical reaction. So the chemical reaction is just chemical equilibrium. So I have already told you, to understand the chemical equilibrium, it is all heat, energy, enthalpy, entropy, temperature, pressure, all conditions, catalysts are responsible. So if I say enthalpy, enthalpy means it is heat content of the substance. If I say entropy, means randomness, haphazardness. The more molecules are moving in all direction, that is called entropy change, and that is responsible of changing the reactant into product. Then free energy, that is called Gibbs free energy. That free energy will determine whether equilibrium will be shifting or not. If Gibbs free energy is minus, means there will be more product formation. If it is plus, it means it will be reversible reaction towards left side reactant. So all these factors I am going to give one by one. But here, let me give that example. Once you are having very hot, steaming cup of tea on table, that is your system. And after few minutes, the heat energy will be transferred slowly to the surrounding. So surrounding is your atmosphere, surrounding area, and your cup of tea which is containing lot of heat, amount of heat, energy in the form of enthalpy will be called a system, and it will be slowly shifting towards surrounding, and one stage will come where it will form equilibrium. That is called chemical equilibrium, and equilibrium is going to explain everything, that how far you are going to get the product and how you can disturb the equilibrium. With that you can get more product, whether it is reversible or irreversible. Reversible means where reactant can be converted into product and product can be again reversed into reactant. But irreversible means once reactant is converted into product, you cannot reverse it. For example, if you take egg and boil the egg, after boiling the egg, you cannot, it is irreversible reaction. You cannot reverse back to original egg. But water, if water is at 0 degrees centigrade, it is solid. And once temperature is decreased, maybe it is 20 degree, that solid is converted into liquid, and again that liquid can be converted into solid. So that is reversible. So these conditions are there. So I am going to give some equation, with that you will understand. So here in a very simple explanation, the equation is written and that explanation is given, that is A, B and then Mn, they are the species involved in reactant and in the form of product. And then small a, small b, small m, small n, they are the coefficients, and K stands for constant, equilibrium constant, and big bracket is the indication of concentration. So that is the explanation of this equation. So here, number one, all chemical reactions are regarded as chemical equilibrium. Make it so all chemical reactions, that is correct, equilibrium is given here, all chemical reactions as we know the principle of equilibrium, so are therefore applied in general chemical reactions. So here we can make the sentence, because I am just missing, all chemical reactions are regarded as equilibrium. Because once we have already given the example that chemical reaction is regarded as equilibrium. Chemical equilibrium means reactant are converted into product, and that equilibrium are therefore applied in general chemical reactions. For example, the same reaction, it is given here, AA plus BB, this is the sign of reversible reaction. Product can be reversed into reactant M, and NN. For this reaction, the equilibrium constant would be K is equilibrium constant, capital M in big bracket, coefficient M small, then N is in big bracket, coefficient N, then A is in big bracket, coefficient A, and big B, that is upper side B we call it, and small size b, coefficient, and these brackets, they indicate the concentration. So here A, B, M, N are chemical species. These chemical species, some are involved in as a reactant and some are in the form of product. So A, B, M, N, they are all chemical species involved in the chemical reactions, and small a, b, m, n, or lower side a, b, m, n are the coefficients in the balanced chemical equation, and where k is known as equilibrium constant. So here I am discussing the thermodynamic requirement, and I have already told you thermo means the heat energy, dynamic means power, and once work is done, it is second law of thermodynamics. So here that free energy, what it is associated with any atom or molecule, these species which are under reaction means they are system, and the energy what is associated with atom and molecule, that is called free energy and known as Gibbs free energy. So Gibbs free energy plays very important role. If the magnitude of Gibbs free energy is not negative, then reaction will not be spontaneous. So here that is I have given. And number 2, thermo means heat, dynamic means power. So here what's power? And the thermodynamic is the relationship of heat and work done and energy content of a reaction at equilibrium. And number 3, the magnitude of equilibrium constant, that is capital K, determines the extent to which the forward means from reactant to product forward and backward reactions has taken place, and it is related to standard free energy, and that standard free energy is called known as Gibbs free energy, and it is represented by capital G, that is delta G means it is changing from G1 to G2 to G3, so that is represented by delta G. Delta stands for change of free energy. Number 4, the first thermodynamic requirement of organic reaction is that energy of system be minimized. That I have already given you the example. That I am calling system means reaction. System means where the very hot cup of tea kept on table, and how it is going to change into equilibrium very quickly. That is energy of a system be minimized. So from that cup or from that reactant to product, it is very important that how quickly the energy is transferred from system to surrounding, from reactant to product. The change of free energy gives energy. That is going to determine very important of your K, that is equilibrium constant. So energy of system be minimized. For this purpose, Gibbs free energy, that is G, is universally measured as the chemical energy associated with the atoms and molecules. That I have already given you in the beginning. Different type of chemical energies are associated, and which is responsible of rotational energy, vibrational energy, electronic energy. In order for a reaction to occur in all chemical species. So in order to occur the chemical reaction, whatever species we are taking, like we have given the example of A, B, Mn. So here all species, there is free energy is given and by delta G, and a chemical reaction takes place spontaneously if the delta G is negative. If delta G is positive, the reaction will not take place. Only reaction is possible where reactant will be converted into product if the standard free energy, which is called Gibbs free energy, is negative. So here I'm going to stop the thermodynamic requirement. It is very, very important for organic chemist or any chemist. What reactions are taking place, they must understand very clearly the thermodynamic requirement and kinetic requirement. So first I will finish the thermodynamic requirement, and after that I will switch over to that is called kinetic requirement, means rate of the reaction. What are the factors to determine rate of the reaction? With this I will stop. Thank you very much for watching the lecture.